In this lesson, we are going to learn about the thermodynamics of a thermos flask. A boy is having a break. He drinks orange juice taken from a flask. He eats some snacks and tastes a cup of hot soup taken from another flask. We heat food in an oven and cool them down in a refrigerator. How do we use a thermos flask to store both cold and hot food? Place a glass of cold orange juice and a bowl of hot soup at room temperature. Record the room temperature first. Then place thermometers in the glass and bowl. Observe what happens. Record the readings on the thermometers after some time. The orange juice will warm up to room temperature, while the hot soup will cool down to room temperature. Heat transfer between the objects and surroundings causes them to reach the same room temperature. What keeps the soup hot inside a thermos flask? The concept of the thermos is to prevent the transfer of heat into or out of the thermos flask. So if we have hot liquids or cold liquids in the thermos, the temperature will be preserved as much as possible. There are three processes involved in heat transfer. They are conduction, convection, radiation. Thermos is a brand name for a vacuum flask. The scientific name is a Dewar flask, named after the Scottish scientist Sir James Dewar, who invented it in the year 1885. However, he used it for scientific experiments. He never intended it to be used as a daily appliance. Heat transfer can occur in three ways: conduction, convection, and radiation. Conduction is the transfer of heat through a substance from a hotter region to a cooler region without physical movement of the substance. In a thermos flask, conduction can occur only at the points where the two walls meet, at the top of the bottle, and through an insulated support at the bottom. Convection is the transfer of heat through a substance from a hotter to a cooler region by the flow of the substance. If two objects of different temperatures are separated by a vacuum, then the heat transfer between the two objects is minimum. If that third medium is considered as a vacuum, then the heat transfer is minimized, or there will be no heat transfer. Radiation is the transfer of heat from a hotter to a cooler region by electromagnetic waves. Conduction and convection needs a medium. Radiation does not. The inside of a thermos flask is silver-coated. It reflects back energy radiation that would cause cooling. Thus, all three types of heat transfer are prevented in a thermos. So the thermos will keep the hot soup hot and cold juice cold. Let us learn more about the inner parts of the thermos flask. Click on the labels to know more about them. Do hot things in the thermos ever cool down? There are two paths in the thermos flask for heat transfer to occur. One is through the cork or the cap, and the other is through the glass. Although the heat transfer in these paths is small, it is not zero. The thermos is designed to limit heat transfer through the walls of the thermos. This keeps the internal temperature of the thermos constant for a long period of time. What will happen if we put a hole in the inner wall of a thermos flask? Will it work? What will happen if we put water in place of vacuum? By punching a hole in the inner wall and letting air in, the thermos flask wouldn't work very well. If water is used instead of vacuum, then the transfer of heat will be faster.
Drag and drop the correct type of heat loss prevented in the thermos flask with respect to its parts.
A thermos flask is one of the examples of how the thermodynamic concept is applied in our everyday life. The idea of the thermos is to slow down the transfer of heat from one place to another. Hence, no matter what material you have in the thermos, cold or hot, the end result is the same. Temperature is maintained as much as possible.